Hi everybody, this is Rob Swatsky from the York campus of HAC, and in this podcast we'll be reviewing the anatomy of the different types of blood vessels. There are 5 main types of blood vessels: the arteries and arterioles, the capillaries, and the venules and veins. Arteries are the vessels that carry blood away from the heart to the body's organs. Large diameter arteries branch into medium diameter arteries, which branch into small arteries, which then divide into smaller arteries called the arterioles. Arterioles enter into tissues and branch into microscopic thin-walled capillaries, which is where gas, nutrients, and wastes are exchanged. Capillaries merge and fuse into small veins called venules, which combine into large diameter veins that carry blood from the body's tissues back to the heart. There are 3 layers, also called tunics, that make up the blood vessel wall. Each of these layers consists of different tissues, such as an inner lining of epithelia, a middle layer of smooth muscle and elastic connective tissue, and an outer covering of connective tissue. The innermost layer is called the tunica interna, or intima. The middle layer is the tunica media, and the outer layer is the tunica externa, also called the adventitia. The different types of blood vessels vary in the structure and arrangement of tissues within each of these 3 layers. This variation directly correlates with the specific functions of each blood vessel. The tunica interna, or intima, serves as the inner lining of a blood vessel and makes direct contact with the blood flowing through the lumen, which is the inner space within the blood vessel. Think of the word illuminate, which is when something is made clear. The innermost part of the tunica interna is the endothelium. This is a single, thin, smooth layer of simple squamous epithelium. It is a continuation of the endocardium that lines the heart and covers the heart valves. The endothelial cells perform various roles, such as improving the efficiency of blood flow. Their smooth surface minimizes friction, secretes chemicals that cause vessels to constrict or dilate, and helps with the permeability of the capillaries. Directly under or deep to the endothelium is a tough supporting layer of connective tissue called the basement membrane that binds the endothelial cells to its connective tissue. It is made of collagen protein fibers that give it strength, but also allow stretch and recoil. The internal elastic lamina is the outermost layer of the tunica interna, which consists of a thin layer of elastic fibers perforated with small openings. It looks like Swiss cheese in the diagram. This layer allows chemicals to diffuse from the tunica interna to the tunica media. The middle layer of the blood vessel wall is a variable layer of smooth muscle and connective tissue called the tunica media. Media means middle. Remember, the muscles are in the middle. It consists of circular rings or belts of smooth muscle tissue and an overlying external elastic lamina of elastic connective tissue of varying thicknesses, depending on the needs of the vessel, which gives it the ability to stretch and recoil. Arteries, for example, always have a thicker tunica media. It is found as a thicker region in most vessels. Its main function is to adjust the diameter of the blood vessel's lumen, either decreasing it through constriction or increasing it through dilation. This has a significant effect on the regulation of blood pressure and the rate of blood flow. When the smooth muscle contracts during vasoconstriction, usually triggered by stimulation of the sympathetic division of the autonomic nervous system, the fight-or-flight system, the lumen decreases in diameter. The blood vessel will increase in diameter during vasodilation, which is the result of a decrease in sympathetic stimulation or due to changes in blood pressure or the actions of chemicals like nitric oxide, hydrogen ions, and lactic acid. Also, when an artery or arteriole is damaged, the smooth muscle in its wall contracts, causing a vascular spasm, which helps reduce blood loss out of the vessel. The tunica externa, or adventitia, is the outermost layer of the blood vessel wall. It consists of protein fibers, including collagen and elastic fibers, that protect the blood vessel, but also help anchor it to neighboring tissues. The tunica externa also contains nerves, and in large vessels, its own network of small blood vessels, called the vaso vasorum. This is Latin for the vessels to the vessels that nourish the tissue layers of the blood vessel wall. New blood vessels grow through the process of angiogenesis, which is regulated by several peptide proteins. Angiogenesis is an ongoing process occurring throughout life, from embryo to fetal development, to repair of damaged tissues, to regenerating a new uterine lining following menstruation, to growth of new coronary vessels around blocked arteries.